Audio Jungle. Audio Jungle.
Right. Types of stress. Types of stress. Here we'll talk about the basic two types of stress. Basic two types of stress. It's nothing but direct stress, indirect stress. Now, direct stress again will have two types. Normal stress and it's a shear stress. Shear stress also called tangential stress. Okay. Shear stress also called tangential stress. Now this normal stress again will have two types. It's called tensile stress and compressive stress. Okay. And indirect stress will have two types basically. Nothing but it's nothing but bending stress. It's a bending stress and torsion. And torsion. Okay. These are the types. Okay. Now coming to this direct stress, this direct stress also called simple stress. Okay. So first we'll talk about the direct stress or simple stress here. So direct stress or simple stress. So if when it will be called direct stress, listen carefully, you will understand. Uh, direct stress, why it is called direct stress? Because uh, if any object is what uh, inducing stress, and that stress under direct loading condition, if direct loading condition is there, then because of that load, whatever the stress you will get, it is because of the it is called as a direct stress. So if direct loading is there, then whatever the stress is what induced in the object called direct stress. Now the example I will show you, like two types of the different case, different case I will show you, so you will understand. See, this is the object. For this object one, this is the another object, and this is the third one. Okay. Now for this object, maybe load will be acting something like this. Okay. For this object, maybe load is what acting like this. For this object, maybe load is what acting like this, means over this surface. Suppose this is the surface, and on this surface load is what acting like this. Okay, very simple. That can be possible. I can draw this 3D surface, and yes, that load may be acting something like this. Huh? So just listen, this load P, this is also P, and obviously this is, you can say this is the F. So I can say this type of loading, when force is what, pulling force. See that this two force, both forces are pulling, means direction is what, outward to the surface. So this is the pulling force. So pulling force or load called as tensile load. See here, this is what, pushing force. Pushing force means what? See, both of direction of the loads here, both side, you check, it is pushing force. In this pushing force, if you see, the direction is what, inward. So inward direction will be the pushing force, and outward direction will be the pulling force. So for the pushing force, it is also called compressive load, because it is trying to compress the object. Compressive load. And here see, the both cases, this two direction I have shown you. Similarly, it is possible here also. If you check here also, it is possible something like this. See, that can be possible in this direction also, and here also possible. If you see, hmm? any one side you can see. So this type of force called as shear force. What it is called? Shear force, or best tangential force. Tangential force. Okay. So based on this different types of force acting on the object called as, based on this different force acting on the objects, will have a different types of the stress. Like case one first, what is that? See, this is the object, load is what, acting P here. So this type of stress, called whatever the stress you will have, because load is now tensile load, and where it is acting on this cross section. It is acting on this cross section basically. Here you just say area is A. So what is the load? Tensile load. P is what? Tensile load. Just now I have shown you it's a tensile load. So what is the stress now? Tensile stress. Tensile stress sigma. Okay. It's a tensile stress sigma T, I can say. It's a tensile load divided by area. Okay. Always remember, because of the tensile stress, because of the tensile load, what you will have? Elongation. What you have? Elongation. Means length increases. Yes or no? Yes. If you see the forces acting on this object, so once load is what, acting L, so obviously the length of this object will be increasing. By, because we have a pulling force. So always remember, length increases. So whatever the delta L, that length increment, that will be positive. Okay, I will explain you strength, then you will understand. Second case. Second case, case 2. In case 2, what is happening? This is the object, see. This is the object now. Where the load is what, acting, see. Load is what, pushing force, it is inward, P. So what is the stress? Obviously it will be compressive stress, क्योंकि लोड जो है वो कंप्रेसिव लोड है. ठीक है, तो कंप्रेसिव स्ट्रेस इज नथिंग बट कंप्रेसिव लोड compressive load by area. So this is nothing but sigma c, compressive stress, sigma c, called compressive load. Obviously it is P by area A. right? But what is the nature of compressive stress? It will try to shorten the length. What it will try to do? See, it will try to shorten the length, means delta L. Shorten the length means length decreases. Why length decreases? Because see, pushing force, both side it will try to compress, then length will be decreasing. So length decreases in this situation, hence delta L will be minus V. So whenever compressive stress will be there, your length, change in length will be negative. Why? Because it is trying to compress the object. But what is happening here? It is trying to elongate the object. So in case of the tensile stress, tensile load by area, but change in length will be increasing here. And similarly, in case of the compressive stress, it's a compressive load by area, but there is the shorten the length, or length will be decreasing. So whatever the change in length, it's a delta L. Delta L is nothing but negative. Delta L is nothing but negative, right? Delta L is nothing but negative. Are done. Two cases is done. What is the third one? Third one is nothing but shear stress, na? Shear stress. So whatever the area here you have taken in both cases, I must write, whatever the area you are writing here, this area is always a cross section area. What area? Cross section area. Okay, here you need to remember, it's a cross section area. Both cases we will have to write cross section area for both. But for the shear stress, we have to write surface area. We have to write surface area. Okay, we have to write surface area. All right. So this is also cross section area. Cross section area. But when you will talk about the shear force, okay, that is nothing but shear stress. I think case 3. Sorry, case 3. What is case 3? You can have the separate diagram you have to draw. Suppose this is the object now. See, this is the object now. You can say this object is what fixed at the bottom. This object is what fixed at the bottom. And this object, if I show you the 3D diagram, so it will be something like this. Something like this, right? Okay. You can say here it is. Right. So how the shear stress will be acting, I'll show you on 3D. It will be more clear that shear force will be acting something like this. This is the shear force or tangential force. Okay. This is the shear force or tangential force. One single force I will show you, then it will be more clear. Okay. So it's nothing but, sorry. Now see, this is the shear force. This is what shear force, which is also called tangential force, which is also called tangential force. How this object looks like once any object we have here, okay, when any object we have here, and if I show something like this, if any shear force will be acting, then how this object will looks like after getting deformed, how it looks like. It's very simple. Now this object we have here, but for this object, if tangential or shear force is acting something like this is the shear force. or tangential force acting on the surface of this, then this object will deformed. And how it will be deformed? Because this load tangential force is what acting in this way, then this object will deform something like this. You can check and tell me. This object will deform something like this. This object is what? Something like this. Means earlier object was A, B, C, D, but now object becomes A, E, F after deformation. You must try to understand. Once load is what acting on the surface, it's just like a book. If you see book, how the books, huh? Very thick book, if you see, something like this. This is what books, right? This is the book. But if you apply force, put your hand here, na? Put your hand here, and if you push in forward direction, then how that book will be deformed? How that book will be deformed? Very simple. The book will deform something like this. See, wait. The book will deform something like this. See, the book will deform something like this. You just focus, you will understand. Means this upper part will be more displaced from the downside part, because if you can practical also, you can do at your home. So the upper portion, because here force is what acting, so this upper surface will move more compared to the bottom surface. So similarly here also, see, bottom surface is what fixed. Once you apply load on the upper surface, so this object is what moved. Upper surface is what moved from B to C, it moves E to F. So here angle will be formed. Yes or no? This angle is nothing but phi, I can say. Okay. Now if you ask what is the shear stress here, simply shear stress, so it's nothing but shear force means tangential force divided by area. That's all. Shear stress is nothing but shear force by area. This is all about stress. Still we have to talk about the strain also.